If one day you are given positive real numbers a, b, and c, and you were told that the following inequality holds for any real numbers x, y, and z that you can possibly find, you scratch your head and you ask yourself, can you show that this is true? Well, the first thing that you might say is that the right hand side looks quite messy and it is really hard to see what is going on. An intuitive approach will be to first try and distribute the terms and see what we will get. So we can see that you end up with 2 times the square root of ab over b plus c times by c plus a and xy. And the remaining 2 terms results from cycling the variables abc and xyz. And now something fishy is going on. As if we were to have terms without the square roots, we will just get the terms that appear in the expansions of x minus y the whole thing square, y minus z the whole thing square, and z minus x the whole thing square, as they are the square terms x square, y square, z square, and the cross terms xy, yz, and zx. So bearing this in mind, this may point us towards a method of proving this inequality, which is sometimes called sums of square, aka SOS method, which is by moving all the terms to the left hand side and expressing them as a sum of squares to show that the whole thing is non-negative. So the big question now is, how do we express the left hand side in some square terms? Well, the trick here is to choose our candidates for completing the square, which we know these 3 terms must be our cross terms, and based on this information, I'm going to rewrite x squared as b over b plus c x squared plus c over b x squared. Notice that they sum to x squared. Doing the same thing for y squared and z squared, we will get similar expressions. By now, hopefully you should be able to see that there are 3 squares expressions that can be formed, which can be seen by rearranging the terms into 3 groups and rewriting some of the terms as something to the power of 2. These 3 expressions are really familiar, and indeed, they are the expansion of a second degree binomial, which can be neatly rewrite as a sum of 3 squares. So this shows that it must be non-negative, which by going backwards, our original inequality must be true. And if you are curious about the equality case, it happens only when all the square terms are 0, which you can figure out that x, y, and z must be in the ratio of square root of a times by b plus c to square root of b times by c plus a to square root of c times by a plus b. And all such triplets of real numbers x, y, and z will give equality. Now if you have reached here, make sure to subscribe to the channel for more math videos. And actually proving mathematical inequalities needs a powerful tool, which is the AMGN inequality. To learn this tool, be sure to click on the video on the screen now, and I'll see you in that video.